As a nice cold spell hits the UK, today we're going to talk about solar batteries and how they perform in the cold and what you need to do to increase that performance. I've been getting many questions recently on the Solax Support UK Facebook group about the solar installations and why suddenly people are having battery problems. So we're just going to look into that today and discuss the symptoms and solutions to batteries and cold weather. The battery technology used in solar installations is usually LiFePo4, lithium chemistry. One slight drawback of this technology is that in low temperatures, charging and discharging ability is impaired. You will notice a reduction in the potential of charging the battery under 15 degrees, and it gets slowly worse until 0 degrees, at which point it won't charge at all. As far as discharging goes, the battery will discharge down to about -10 degrees and then it will stop operating. The BMS that controls the battery, or the battery management system, detects the low temperature and limits the amount of energy that you can charge or discharge from the battery at certain temperatures. So the ideal operating temperature of the batteries is between 20 and 30 degrees. Anything under 15 degrees and the performance will be impaired. With this lithium technology, if the battery is charged too quickly under a certain temperature, the chemical composition of the cells is permanently changed and the battery is damaged. So it's very important that the BMS reduces the charging level below certain temperatures to make sure that the battery is kept in good health. This means that you'll notice the reduction in performance when the weather gets cold. So here are a couple of examples where you can tell that the battery is too cold because the behavior is not quite right. There's 1.48 kilowatts of PV energy being generated from the array, and then it's split between the battery, the loads, and the grid. Now, usually in self-use mode, the loads would be fulfilled, and then after that, it would charge the battery up to the maximum charge rate of the battery, and then export to the grid. Now, the battery is only at 22% SOC, and it's only accepting 467 watts of charge. Now, normally all the remainder of the charge over the top of the house use would be going to charge the battery. So you would expect it to be roughly 1.4 kilowatts going to the battery. So in this case, the battery is too cold. The battery management system is restricting the charge rate to 467 watts, and it's sending the remaining 932 watts to the grid. So in this instance, you can see that the battery is too cold. You can also look at the weather. So 2 degrees, max 5 degrees. It shows that if this is an unheated installation and the battery doesn't have heating capacity itself, then it's likely that the battery is going to be too cold to charge at its full rate. This is another example from the Solax app. We're looking at the statistical information now, and this is the battery temperature. So degrees C at the side and the time. So you can see overnight it's dropped from 3 to 2 to 1 degree, increased to 2, and now it's down at 0. So again, this battery won't be charging because the temperature is too low. At 0 degrees, it almost won't charge at all. It's just a very small trickle charge. Let's just take a look at how the cold impacts the battery performance. So I've got a few figures here as a rule of thumb. Now, this is not accurate, but it's a general rule of thumb as to how the battery will perform at what temperatures. And this is in general for the lithium technology used in solar installations. Any temperature under 15 degrees, you will get 1 amp per degree of battery charging performance. So you can see from the table on the screen that 12 degrees, you will get 12 amps of battery performance. 7 degrees, for example, you would get 7 amps of battery performance, right down to 0 degrees, where the batteries will charge at 0 amps or just a very slow trickle charge. So in general, that's what you can expect out of the battery. So what does that relate to in terms of kilowatts or power? Well, that really depends on what battery configuration you have. Because the batteries are connected in a serial configuration, the more batteries you have, more power you'll be able to charge them with. We'll take the T58 as an example because at the moment it doesn't have built-in battery heating. So the T58 at 10 degrees, that will be a maximum of 10 amps. Now, if you just have one T58, then the voltage, the working voltage is approximately 115 volts. You multiply that by 10 and that will be 1.15 kilowatts. So that is the maximum charging rate you can expect at 10 degrees from one master T58 battery. If you add a second slave battery to your T58 and you have two, it doubles the voltage to 230 volts and the 10 amps would remain the same charging rate. So you would then expect 2.3 kilowatts as a maximum charging rate at 10 degrees C. And exactly the same, if you increase that to 3 batteries, which is the maximum number of T58s you can have on an X1 inverter without a parallel box, then the voltage is increased to 345 volts, and again, the amperage will be 10 at 10 degrees, and you could expect 3.45 kilowatts of a charge rate. So let's look in the Solax app to find out what your battery temperature is to see if you have a cold battery issue. Just launch the Solax Cloud app. Now this demonstration is based on 3 T58 batteries in an unheated garage, and you can see that the weather is bright today, but it has a minimum temperature of 2 and a maximum temperature of 5, so there's potentially going to be some issues with cold. If you scroll down to the battery tile and click on the battery tile, the T58s have a cell temperature reading, a current cell temperature reading, so you can see my batteries are between 12.6 and 14.6 degrees C as a cell temperature. Now some batteries don't show that figure, so I'm going to show you another way to access a graph to see the graph over time of the battery temperature. So heading back to the main screen, if you then go down to the bottom to device, and in the device section you click on the inverter which the batteries are connected to, and then scroll down to the statistical information, and from the statistical information graph you're going to select MBMU battery temperature. So this graph may be showing other information, and if you want to show the battery temperature you need to click on the little filter logo here, and we get a whole list of all kinds of items that you can graph, and you need to scroll to the bottom and select the MBMU battery temperature and then click confirm, and this will plot the temperature for each day that you select, and you can use the arrows to go backwards and forwards. So you can see yesterday it went down to 12 degrees, and on the 19th more or less the lowest again was 12 degrees. So it is an insulated garage, but it's unheated, so sometimes it goes below 15. So because there are 3 T58s and it's 345 volts and 12 degrees is going to be 12 amps, I'm not going to have significant battery performance charging issues. So let's just look at the limitations of that. My cold battery at 12 degrees has a maximum charging rate of 4.14 kilowatts, and the normal battery at, let's say, 20 degrees would have a maximum charging rate of about 10.35 kilowatts. So there is actually a big difference, a 6 kilowatts difference between the charging rate of a battery at 12 degrees and a battery at 20 degrees. As far as PV charging is concerned, I won't be generating that much in winter, so it won't affect me all that much, although charging from the grid will take some more time. This rate is also affected by the rating of the inverter. For example, if you have a 5 kilowatts inverter, then the maximum charging rate can only be 5 kilowatts anyway, or 5.5 because they're able to do 10% more. So the actual only difference is between 4.14 kilowatts and 5 kilowatts, so there's roughly 0.8 kilowatts of difference because of the cold weather. Now, of course, as the temperature goes down and the amps reduce, then that difference will be more and more. If you have a bigger inverter, for example a 7.5 kilowatts, then the difference will be between 4 kilowatts and 7.5 kilowatts, which then starts to make more of a difference of 3.5 kilowatts. So just bear that in mind when you're doing your calculations. It's really dependent on the inverter rating as well. So what can you do to help your cold battery? Firstly, check to see if your battery has battery heating fitted. No brainer. Some people have battery heating in the battery and it's not enabled, so we'll go through that in a moment to see how to enable it. If you don't have heating fitted in your battery, well, there have been a few suggestions, and one of them is to create an insulated box around the batteries to help keep them warm. And you can also encompass the inverter inside the box, so you make a kind of cupboard out of the rigid type of insulation, and the inverter helps keep the batteries warm. This of course needs to be removable so that in summer you can remove it so that the inverter doesn't overheat and the batteries don't overheat. And if your battery is located outside, then even an insulated box is normally not enough, and you need to add a thermostatically controlled tubular heater. Something around 60 watts is fine, so just buy one online. You can plug it in, put it inside the insulated box, and it keeps the batteries nice and warm and doesn't use too much electricity. And the last option is to increase your grid charging time. If overnight you're charging from the grid, then it'll need more time because it'll charge slower to get to the battery SOC that you require. So these are some examples of the Solax batteries available. These are T58s, and the V1, V2 and V2.2 do not have any battery heating. The V3, which is not quite released yet, will have battery heating. This is a stacking T30, and in general the stacking batteries all have heating built in because it takes less energy to heat stacking batteries than it does to heat separate wall-mounted batteries. So this is a T30 and that does have battery heating. This is an IES where the batteries are built under the inverter in a stack, and this also has battery heating technology. And these are the HS series stacking batteries. They come in 2.5s, 3.6s and 5.1 kilowatt hour per stacking section, and they also have battery heating technology built in. So as of the 12th of November 2025, this is a inverter and battery compatibility chart. So not only can you see whether your inverter is compatible with different types of batteries, you can also see whether the batteries have heating fitted or not. So I hope you can actually see and read that. It's a little bit small on the screen, but I hope you can make it out. This is how you check to see if the heating settings are available on your inverter. All you need to do is access the remote settings, which I'm sure you've done before, but if you haven't, you need to go to Device and then click on the inverter to which you want to access the remote settings. And then in the function control panel here, you can see the remote settings icon. You can click on that to access the remote settings. Click on the settings heading here and you'll be asked for an unlock password. Now, the battery heating functions are supposed to be more or less a set and forget setting. It's not something that you're supposed to switch on and off and on and off all the time. You could leave it on all summer and the heating just won't turn on because the battery never drops to that level. So you can actually leave it on all year round and then it'll just take effect during winter. That's why this setting is not particularly accessible in the app or on the front screen. So the unlock password for the advanced settings, we're going to use 2014 and click confirm. These are all the advanced settings, and you can see that there isn't any sort of battery heating on these batteries. There isn't a battery heating submenu anywhere. So these are T58 batteries and there's no heating installed. So I'm going to show you an example of remote settings that do have heating installed, and this is on an IES system. So again, we have the remote settings up, and I'm going to click on settings, type in the 2014 passcode for the advanced settings. So in advanced settings, scroll down to the battery heating submenu. So you can see here, this is an IES system and it's got the battery heating installed. If you expand that section, you can see the battery heating is disabled. So if you click on that and click enable and then click confirm, and make sure that after every setting, you click the save button to make sure that setting is applied to the inverter. Okay, so as soon as you enable it, you get some more settings in the battery heating roll down. Okay, so you can see there, if I roll it down, I've got heating levels and then heating periods, heating period 1 and heating period 2. So we're just going to go through what the levels mean. Now, if you have a look at this section, you'll see that the options are low, medium or high. But on some inverters, these options are 0, 1 and 2, but they have the same effect. 0 is low, 1 is medium and 2 is high. And we're just going to have a look at those different settings now. So the 0 or the low level has a minimum temperature of 0 degrees and a maximum temperature of 10 degrees. And this means that when the battery goes down to below 0 degrees, battery heating will start and heat the battery to 10 degrees, and then the heating will stop again. And that cycle will continue. If the battery reduces temperature back below 0 again, the heating will start and bring it back to 10 degrees. On the medium level, or level 1, the minimum temperature is 10 degrees and the maximum temperature is 20 degrees. Same thing again, if the battery temperature drops to below 10 degrees, the heating will start and heat the battery until it reaches 20 degrees. And when it reaches 20 degrees, the heating will stop and that cycle will continue. And the high level, or level 2, is 20 degrees to 30 degrees. So if the battery goes below 20 degrees, it'll heat up to 30 degrees and then the heating will stop. A little bit on the amount of power that the battery heating system uses. Of course, if the batteries need heating, then the power to heat them needs to come from somewhere. The T30 battery here on the screen, it draws 180 watts per module. Okay, so if you have them stacked on top of each other per module, it will take 180 watts while the battery heating is operating. The slightly more modern batteries, the IES and the HS, the stacking systems, they use 120 watts per module. Back in the remote settings, you can see here we have defined heating periods, a little bit like we can have defined charging periods. There's a start time for period 1, end time for period 1, start time for period 2, and an end time for period 2. These can just be left as 0, and the default battery heating will take effect if it's just set here to low, medium, or high. So if that's the case, what are the heating periods for? And this is just a little bit more complicated, and it's all to do with where the energy comes from to power the battery heating system. Inside a battery heating period, the power source, the main power source for the battery heating, has a priority order. So firstly, it's going to come from the PV if there's enough solar to generate enough power to heat the battery. If there isn't enough solar, then the battery itself provides its own power to heat itself. But that only happens if the SOC percentage of the battery is above 35%. If the SOC of the battery is below 35%, then the battery heating will be powered from the grid. If battery heating is enabled, but you're outside of an active heating period, then the battery heating will only operate from PV energy. And if there's no PV energy, it won't operate. So make sure that at the times of night or the cold periods, that you're actually inside an active battery heating period. This is an example in the Solax app with battery heating. So you can see the home screen and we scroll up. And with battery heating, if it's a feature which is available in the remote settings, you'll get these extra icons here. And the middle icon is a battery temperature gauge. And it goes red when the battery's too hot and it goes blue when the battery's too cold. And the one next to it is the battery heating activation icon. So again, that illuminates when the battery heating is enabled and it's off when the battery heating is disabled. So you can keep an eye on your battery temperature and whether the battery heating is working or not just by looking at the battery tile on the front screen. Here's some examples that people have posted online of their homemade DIY Kingspan insulated boxes. So in this example, it's obviously some sort of brick outhouse, and the inverter is outside of the box. But here you can see we've got about 50mm thick Kingspan, and they've got an old sheet, cut it up, put it all around the batteries, and taped it up. It's also important not to have a cold bridge through to the batteries. So if the batteries are standing on a cold concrete floor, you could also put a sheet of solid insulation underneath the batteries to insulate them from the cold floor. Great idea. If that doesn't work well enough, plug in a tubular heater, put it inside the box. Here's another DIY example where the batteries have been sort of boxed in with more bubble wrappy loose insulation and sealed in with parcel tape. Again, it wouldn't take long to do and it helps keep the batteries warm. You should leave a little bit of space in there for airflow, so don't kind of completely wrap the batteries up. They don't actually need to breathe very much, but there should be a little bit of airflow just in case. They have a equalization valve in the side of the battery because it's a sealed unit so that the pressure stays the same inside and outside, but they don't actually need air to operate and they don't emit any sort of gas. So anything like this to help keep the batteries warm if they're suffering in performance is a good idea. And the last option is to increase your grid charging time to make sure that your battery has enough time to charge at a slower rate, normally during an off-peak period, which is usually at night, somewhere between 11 o'clock in the evening and 5 o'clock the next morning. If you're using TOU, you can make a new TOU, especially to increase the charging times, or if you're using the traditional remote settings, go into the remote settings and set the hours to be a longer time for the grid charging. Just bear in mind that if you do enable the grid charging period for a long time, the system will draw from the grid for the whole period, even if the battery has reached its target SOC. So just bear that in mind when you're setting the settings. Thank you very much for watching, and see you in the next video.